Hello, this is Dr. Janes, and today I'm going to talk about a neat little frequency generator that I found online. It goes from 35 megahertz up to 4.4 gigahertz. So if you want to do some experiments, and it was like $29 or something like that on Amazon. I'll have a link down below. If you want to click that, that will help me out. And very cool device. I'm going to go through and test it at the low frequency range, mid frequency range with my spectrum analyzer that I just got, and high frequency range using some very cool old school type technology, 1950s type stuff, mechanical tuned resonators. So this device puts out a signal at the low end about 1 volt peak to peak at 35 megahertz, and tunable. You got a keypad here, so you can type in the frequency that you want. You can tune the frequency a little bit. You can change the tuning steps by using this key over here. I'll go through it all. Turn the power on and off. Can't change the power level. It seems to be fixed as far as I can tell. I don't see any way to change the power level, but you can always add attenuators if you want less power. Add amplifiers if you want more. Okay, so let's take a look at this device. SMA output. Very cool, huh? Okay, so anyway, here's our cheap RF signal generator. And I think I paid like less than $30, around $30 for this guy. And, okay. We'll have to test this guy out to see how he works. Here's the bottom. It looks like we have a SMA out. Fortunately, with some of my other things that I got, like my network analyzer and my spectrum analyzer, I have some short SMA cables. And looks like there is a micro USB input into this guy. Very cool, huh? Let me, I guess, take this. Is it going to come off? Maybe I'll just leave it on for a second. Fortunately, I have some micro USBs always hooked into my computer, so let's see if we can power this guy up. Let's see, is he 50, 50, 90, right? How does that go? Let's get this so we can see that. Okay, so there is our micro USB. Let's plug this guy in if I can. Come on. There we go. Oh, look at that, it's powering up. Frequency. Oh, very cool. Very cool. Let me take off this screen protector thing, I guess. Okay. 0 megahertz. And we got a flashing LED at the bottom, and I believe this is a, let's see if I can get this guy off of here. This should be a SMA output, I assume. Oh, look at that. Very cool. We'll do some testing, see if we can measure frequencies and power out of this guy. Let me fiddle with this a little bit before we take some video of that. I gotta see how this thing works. Okay, so I should be able to test out my lower frequency range with my Rigol O-scope, DS1052, and I modified that one so it goes up to 100 megahertz bandwidth. And so I'm just fiddling with some of these function keys here. It's got the number pad over here. 1 through 9 and a 0 right there. And then it's got plus or minus, which tunes the frequency up a little bit. It's got an OK and a cancel. Okay. And then there's this key down here, and when I hit that, it cycles through 1K, 10K, 100K. And let's just try doing some stuff. I noticed that so I won't get a trigger if I'm at 1.01 megahertz, and I'll just start clicking this up. And then when I get up to, I thought it was about 100 megahertz, it would turn on. Oh, where's my trigger? Oh, my trigger level's too high, maybe. Oh, maybe because it's at 1K, it should be at just 1M. Oh, let's turn it on before. Now, I figured it was because, well, see, the description says it's from 35 megahertz to 4.4 gigahertz. So, I don't know, this thing had a signal a little bit ago. Let's see if I can figure out how to get that back. Oh, okay, so I hit minus, minus. I don't know why that would make a difference. So the plus and minus tunes it, but at the very, what is that, 10th of a megahertz or something like that. So 100 megahertz seems to be making a signal, and let's try our cursors and see if we measure 100 megahertz, which would be about the limit of the scope. Okay. And it does indeed say about 100 megahertz. Okay, so I wonder if I can bring it down to 30 megahertz. Let's try that. We'll say clear. There's a clear function there. And here's 3, 0. And of course, 0, 0, 0 would be 30. And let's try this. Oh wait, 35. I'm sorry. The description says 35 megahertz. Let's try 35. So clear. 3, 5, 0, 0, 0 megahertz. Okay, whoa, look at that. It's like a square wave. Okay, for some reason, I don't know, it's not turning on the signal unless I hit the minus, minus, or the plus, plus. Maybe there's an enter key. Maybe we gotta hit OK. Let's just try that again. Let's try clearing that. Okay. And right now, I'll just re-trigger this, turn the trigger off and on, so that there's no trace there. Okay, 35, 0, 0, 0. And let's try hitting OK and see if that turns on the signal. Okay, so that's how we do it. So you type in the number, the frequency, and then OK. And you can twiddle the frequency up and down a little bit. It looks like I'm going a little bit below 35 and it's still not cutting out. Can we do 30? 3, 0, 0, 0, 0. Okay. Okay, it won't come on with 30. Let's see. Oh, 300 it will though. Let's clear that. Okay. I can go a little bit above. You know, see, like sampling rate is actually 1 gigasample. So, but actually, let me see. What is the amplitude of that? Let's turn that guy back on. 35 megahertz, and we're at 500 millivolts, and so it's about, what's that? 1 volt peak to peak. See, 1 volt peak to peak. Square wave. I'm not sure if there's a way to change the amplitude. Let me knock that up a little bit more. Okay, there we go. Pretty cool, huh? 35 megahertz. Let's go to, let's try, let me turn this menu off. Okay. Let's clear that, and we'll just try 100 megahertz. Okay. I'm wondering what happens if I change this division to 10K. And if I change that to 100K, I'm not really seeing a difference. So a 1M, I'm not sure what that, I'm going to have to maybe look at the manual or something. 1K, 10K. I'm not seeing a difference as I switch that between 100K, 1M. Okay. Maybe I'll take a look at the manual, but I bet it's probably really horrible. If there is one. I don't think there is one, actually. Here's our box and our wrapper that it came with. And I think there is no manual with this thing. So, that's the mystery button right there. I'm going to ask you what that's doing, but it doesn't seem to change the frequency. Okay, so we're at 100 megahertz. Let's try 200 megahertz. Okay, so we're at 200 megahertz. And of course, this scope is not in calibration at that frequency. But I can always bump up the amplitude. So we're definitely seeing a signal at 200 megahertz, but the amplitude's probably not right because the analog bandwidth is not going to be good up to this frequency. Just out of curiosity, and we can tune this thing up and down with these up and down buttons. Okay. And you know what we could do? I could test out maybe some of the higher range with my spectrum analyzer. That would be a cool thing to try, huh? Let's go up a little bit higher. We'll clear that. 300 megahertz. Okay. And our signal's getting small. But that would probably, let's see, get those on the peaks. And yeah, I could see that's probably about 300 megahertz. Let's see if we can go up to 400. Still measure our signal. Oops. We'll clear that. Oh, very cool, huh? For some reason, 400 megahertz. Try that again. 400 megahertz. Okay. Look at that. We're getting close to the Nyquist limit, I think. And it's hard for me to measure that because it's not very good resolution, but yeah, it's probably about 400 megahertz. Let's, I just got through doing a video on this interesting spectrum analyzer that I have. So, maybe we'll try seeing if we can measure this with the spectrum analyzer. And I might put the attenuation on the spectrum analyzer and make sure we don't burn that thing out, because that would be a travesty. Okay. Okay, so I just put the antenna on the high end of my spectrum analyzer because I didn't want to burn it out, and I'm not sure if I trust this dB attenuator, and I don't have any SMA attenuators, and it, you know, this thing's measuring like microwatts probably, and this thing's putting out like milliwatts, or yeah, I just don't want to burn it out. So let's just test it. We'll test it at the 400 megahertz level. Okay, 400 megahertz, and then we'll click OK. Okay, and see, there's a signal that shows up there, and the cursor's saying it's about 400 megahertz. So I'm just picking up radio, stray radio noise. I don't know what all this other stuff is. Let me actually unplug this guy and see if all this other noisy spectrum stuff is coming from this guy right here. Okay, I guess I think it is. Yeah. See, I unplugged it, and all that other freaking noise is coming from it. Okay, let me try plugging this guy back in, and then we'll maybe try some other things. See if we can see the spectrum up higher. Okay. Okay, so I got brave and I did plug it in after I put the attenuation on full. And it looks like we're seeing a good spectrum there at 400 megahertz about. And let's cancel that. And we'll try doing 500 megahertz. 5, 0, 0, 0, 0. Okay. Okay. And there we go. We're seeing a peak at 500 megahertz. Again, very cool, huh? Let's see, the cursor is saying 500 megahertz. So, let's clear that. We'll try 600 megahertz. Okay. Oops. Too much. 600 megahertz. Okay. Look at that. Very cool, huh? 600 megahertz. Okay. And again, we can shift this, twiddle this frequency up and down. I don't know if there's a way you can, oh, maybe you can change, oh, maybe that's what this is for. Oh, see, I figured out what this is for. That changes how many divisions your twiddling thing works. Look at that. So I can change it at the 0.2 level now. If it's at 100K, when I push the up or down frequency thing, it changes it by bigger divisions. It changes it by this decimal point. And if I hit it to 1 meg, I'll see it's changing at 1 megahertz levels now. I see. So now I can tune that frequency up. 620, 630. You can see the frequency is shifting on this guy over here. Okay, very cool. So I think I figured this thing out completely. Let me get out of this because I don't want that in the way. Let's clear that and we'll go up to 700 megahertz. Okay. And there we got our peak at 700. And I guess again, let's go up to, what the heck, clear 900 megahertz, which is going to be the limit of our little spectrum analyzer here, 960. Okay, so we're at the top, kind of near there. And let me just twiddle, well, or we want to change this to the megahertz scale. Okay, there we go. Oh, where did our signal go? Oh, there it is. Okay. And we will twiddle it on up. 9.5, 9.13, 9.15, 9.20. Okay. 938, and I believe 960 is the max this spectrum analyzer can measure. So we're gonna 940, 950, 955, 958, 59, and we are maxed out here. We went off the top, I guess. There we go. So that is the limit. So we've measured almost up to a gigahertz, and this thing is still claiming that it goes up higher. It goes up to 4 gigahertz, 4.4 gigahertz. So I'm going to have to do some other fancy things to test this signal generator up to higher frequencies. Should be interesting though, huh? Let's turn this off. Cancel. Okay. And now our signal's gone. Okay, let me unhook this setup and we'll try to do something else. Should be interesting. Okay. Okay, Okay, so here's an old school way of measuring really high frequencies. And you know, they've been doing microwaves for a long time. And so this device, this signal generator here, goes up to 4.4 gigahertz, right? And so let's just do some testing. Let me explain what's going on here. First, I have my signal generator, and I have it hooked up to a dip meter. So this has got a mechanical resonant cavity here, and as you tune this wheel up here, it will tell you what frequency that this cavity is resonant at. And I have it tuned to just below 4 gigahertz. I don't know if you can see that, but there's a little writing on here, and you look between these red bars, and there's a line right there, and that tells you exactly where we're tuned to. And here's 4 gigahertz right there. And then we have a diode detector, which is basically a high-speed diode going into a voltmeter. Okay, so let's go over here, and we will type in our frequency. Let's see, 4. Oops, that's a 1. Clear that. The 4 is this button up here. 4, 0, 0, 0, 0, 0, 0. So that's 4,000 megahertz, or 4 gigahertz. And let's click the OK button. And when we do that, we see power coming out of our diode detector here. Okay, so this is supposedly 4 gigahertz, and let's just watch this guy as we twiddle the knob. Okay, so we got the frequency there coming up to 4 gigahertz. See that? 4. And what should happen is there will be a dip in the power as we go through the resonance. Okay, so keep on twiddling and turning the dial up here, like so. Okay, see, see, there's the dip. And so the dip is a little bit past 4 gigahertz. It's like 4.12. What are these units? This is 4.1 over here. So that's 4.01, 02, 03, 4.03. So either this guy is off a little bit, or it could be that this mechanical resonator thing is not what it should be. A 1950s type contraption. But anyway, looks like we are putting power out, and you'd have to calibrate this crystal detector to see what that power is. But we are definitely, let me turn the power on and off. Okay, so we'll hit OK. Okay. See, the power goes away. I hit OK. And when I hit OK again, the power comes back on. I wonder if there's an indicator. Okay, yeah, okay, so there's a little indicator on here. So if those arrows there are pointing that way, it's got power coming out, and if it's not, then it doesn't have power coming out. So we're definitely getting power out, and it is, according to our 1950s type contraption here, very, very close to the frequency that we expected. It's a little bit above 4 gigahertz. Okay, let's see if we can get the stuff in frame. Okay. So definitely very cool, huh? 4 gigahertz. Okay. So anyway, there's a cheap little contraption if you want to get up into the gigahertz range and start doing some measurements there. Okay. And this is Dr. Janes, and thanks for watching.